Hi everyone, welcome to Reason with Science. I'm your host Jitendra. This is second episode with Donald Hoffman. Donald is a professor emeritus of cognitive sciences at the University of California, Irvine. He is the author of 3 books, including The Case Against Reality, Why Evolution Hid the Truth from Our Eyes. Here we talk about what is mathematics, interface theory of perception, fundamental nature of consciousness, origin of life, spiritual experiences, and meaning of death. Enjoy the conversation, share, and subscribe to support the podcast. Thank you for listening. Hi, Don. Welcome to the podcast.
Thank you, Jitendra. Good to see you.
Yeah, so it's been a few months that we discussed last time. And I think I would like to start with that itself, which is your theory of consciousness, interface theory of perception, as you call it. If we basically, if I just summarize a bit, that there are mainly 2 elements. One is evolution by natural selection, which doesn't give us an ability to see reality. And the second element is space-time is doomed, right? So how do you combine these 2 points, and where do you stand on this theory after this few months?
Well, yes. So the idea there is that 2 of our main pillars of modern science, namely evolution by natural selection, and then modern physics, so quantum field theory together with Einstein's theory of gravity, both of those pillars of science lead to the same conclusion, and that is that space-time is not fundamental, and that therefore objects in space-time are not fundamental. And that's just what our best science says today. It doesn't mean that it's right, but it means that the best theories that humanity has so far, the foundations of our modern science, very clearly tell us that space and time are not fundamental. Both of them agree. Now, my other step to saying that consciousness is fundamental is independent of that, right? You may think my stuff about consciousness is nonsense. That's perfectly fine. But the other stuff is just theorems of the basic pillars of modern science. So it's a theorem of physics that space-time has no operational meaning below the Planck scale. So 10 to the minus 33 centimeters, 10 to the minus 43 seconds, it ceases to have any operational meaning. And that's not very deep. That's a very shallow data structure. If it was 10 to the minus 33 trillion centimeters, I might be impressed. But 10 to the minus 33 centimeters, that's just a very, very shallow structure. So space-time falls apart, and with it, reductionism, the idea that as you go to smaller and smaller scales in space, you find more and more fundamental laws that are operating on more and more fundamental entities, like the elementary particles of the standard models, what we thought might be the fundamental particles. So that whole reductionist paradigm is also dead. The physicists themselves are finding what they call UVIR correspondences, violations of the reductionist hypothesis that as you go to smaller and smaller scales, you find deeper and deeper laws, and there's no interaction between large scales and big scales. It's just like the small scales determine what happens at the large scales and not vice versa. So there's this UVIR interaction that the physicists are discovering, and it has to do with the fact that space-time is not fundamental. It's a data structure, and it has its own properties as a data structure. And evolution by natural selection agrees. It comes at it from a different point of view than the physicists, right? The physics is saying space-time has no operational meaning beyond the Planck scale. Evolution by natural selection says there's zero probability that any of our perceptions have structures that are homomorphic to the structure of objective reality, whatever that structure of objective reality is. So, by the way, when I say that, you might say, well, how in the world could you know what the structure of objective reality is so that you would know that you're not seeing it? And the answer is you don't have to know what the structure of objective reality is for us to get this theorem. And for those who want to jump in, you have to actually look at the math. But you might say it's logically impossible. You just have to look at the math a little bit more deeply. It turns out you can just show in a number of different ways that the probability is zero. And you don't have to assume a priori that you know the truth about objective reality. You could do things like say, suppose objective reality had a total order. What is the probability that the payoff functions would be homomorphisms of that total order, so that you might have your sensory system tuned to that part of objective reality. And you can prove, well, in that case, the probability would be zero. Then you can go after other things like, well, what about a metric or something like that? And in every case, you'll come up with the answer. The probability is zero. The only exception are some so-called measurable structures, and that's simply because to have a scientific theory, you have to assume that you can do experiments, and that means you have to assume that the probabilities of outcomes are related to the probabilities of events in objective reality. But no other structure than that is required by our theory of evolution, and therefore no other structure is in fact, are we entitled to assume that it gives. So our view on that hasn't changed. And the physicists themselves have marched on. Space-time is doomed. It's not fundamental. Great. It doesn't matter that for centuries people thought that. It's time to move on, and they're finding structures like the amplitude-hedron and cosmological polytope and associahedron. So space-time, it's over. It's not fundamental. We'll still use it, just like we'll still use Newton. We still use Newton's laws. It's not like we just throw them away. We see them as special cases of something deeper. Well, we'll see space-time as a special data structure that is, that derives from something far deeper, and that's just the way science goes. We've moved on, and so from my point of view, the theories of consciousness that haven't moved on are recidivistic, right? They're just like us, asserting that we must use Newtonian mechanics to understand consciousness. Why in the world should we use Newtonian mechanics to study consciousness? It's not fundamental. Well, the same thing is true of quantum mechanics. It's not fundamental. Same thing with Einstein's theories of relativity. Space-time and quantum mechanics are not fundamental. So why should we assume that consciousness, it must be described in that language? The physicists aren't even thinking that physics is described with that language anymore. They're thinking there's a deeper language that's derived from. And it turns out that the physics shows that when you let go of space-time, the structures you get are far more beautiful. And you see symmetries that you can't see in space-time, sort of dual conformal, infinite Yangian symmetry they see when you let go of space-time. And the math becomes simple. Something that if you use Feynman diagrams to compute scattering amplitudes, and you have like 2 gluons in, 4 gluons out, it takes hundreds of pages of algebra. And you have all these virtual particles. When you let go of space-time, it's a single term. You can compute it by hand. There are no virtual particles. They're part of the unphysical baggage that comes with the trying to shoehorn reality into space-time. So you all of a sudden you realize, okay, wow, when you are, as a physicist, if you're stuck with space-time, the math is nasty. You have all these fields that have all sorts of redundancies built into them. You have all these virtual particles that it turns out you don't need, and they actually make the math terrible when you let go of them. Millions of terms turn into a single term. So it's there's no surprise that in the cognitive neurosciences, my brilliant colleagues haven't picked up what's going on with the physics. I mean, this is fairly new. It's in the amplitude-hedron was published in 2013. That's less than 10 years ago. So it's no put down on my colleagues that they're not using what's only been less than 10 years in physics. But at some point we will have to turn around and say, okay, the physics has moved on. It's recent, but physics has moved on, and they have new structures beyond space-time. Well, how are our theories of consciousness and consciousness? How is it going to use this new ideas from physics, and how are we going to connect with them? So that's what we're doing with our theory of consciousness.
Yeah, it's a great start, I think, and slowly we'll unpack all the information. But let's talk about, so one thing that you mentioned is reductionism in science itself. So what is the problem there? I mean, is it the problem reductionism in kind of material sense, that we are always looking for something smaller to account for everything? Or is it, or even if, let's say, we take consciousness as fundamental, still there'll be a problem with reductionism?
Right. So the problem with reductionism is completely independent of anything I have to think about consciousness. It's purely a physics fact. This is the physicists. And if people want to, hear not from a cognitive scientist about this, they want to hear from a real physicist who will give them the real beef, then I recommend just Google this lecture. It's Nima Arkani Hamed, Harvard lectures at 2019. So he gave an entire course at Harvard in the fall of 2019, the semester there. And in the very opening lecture of it, he explains why reductionism is dead. And then throughout the course, you see how dead it is. You see that reductionism is flat out dead, and that you have to find these new structures where the very notion of smallness inside of space is basically irrelevant. But to sort of summarize what the physicists have said about why reductionism is dead. Well, part of the reason is that you just can't go smaller. You get to 10 to the minus 33 centimeters, there's no going smaller. And when you try to, what happens is you actually get bigger and bigger. So as you try to probe reality at smaller and smaller scales, you have to use higher and higher energies. Roughly, the idea is from quantum theory that if you're going to use finer and finer light, smaller wavelengths of light to resolve finer details, well, the energy in that light is going to go up. E equals h nu is the formula. So as the frequency goes up, the wavelength goes down, the energy is going up. And in a world where there's just quantum theory, that would be great. In principle, you could just keep going. As long as you have more and more energy, unless there was some fundamental principle why there was a top limit to the energy that you could access, there would be no problem in principle of going to smaller and smaller scales of space-time. But with gravity, the whole party is spoiled, because as you go to smaller and smaller scales, the energy is getting higher and higher in that smaller and smaller scale. And Einstein tells us that energy equals mass. Mass curves space-time, he tells us. And at some point, the mass is so great that it curves space-time infinitely. You get a singularity, you get a black hole.
Yeah.
And so that turns out that at the Planck scale. So all of a sudden, what happens is the very method that we use for going to smaller and smaller scales, all of a sudden you're going to bigger and bigger scales because the black hole is getting bigger. So reductionism falls apart. So those are the kinds of arguments, and for those who want to hear it straight from a physicist, go to Nima Arkani Hamed, Harvard Lectures 2019, and he's got 25 or more lectures where you can really go in and see why it's reductionism is dead. It's going to take a while for my colleagues, and my colleagues are brilliant, but you can't do everything. You can't be on top of all the modern physics and so forth. You're doing your own stuff. So it'll take a while for them to realize that it's over, just like it took a long time to realize that it was done for Newton, right? It was done for Newton by 1905 when Einstein published special relativity. I mean, it was over. But in 1922, even the Nobel Prize Committee that gave Einstein his prize for the photoelectric effect were very, very clear that it was not for relativity. They didn't buy that. So it's no surprise that it takes a while, even for those who are well informed, to catch up with what the marches of science. But that's the way science always works, right? There's going to be a small avant-garde at first. There are the weirdos that are stretching out of the received opinion, and eventually people realize, oh wow, well the received opinion is the old opinion, and the weirdos actually have the new regime that we have to go with. So that's where we are.
Yeah, so that's definitely true. And once we think about modern science, where it is moving, and because one thing is this empirical evidence where we are talking about experiments, etc. The other thing is the new theories that we are developing, and most of them, they are through something we call mathematics. So of course, some scientists, they will call it a language of science. Okay, and if we talk to mathematicians, they will say, okay, no, this is also a science. So how do you look at mathematics? I mean, people or scientists have gone even to the extent to say that our universe is mathematics in general, right? So what do you think about it?
Yeah, the last point you made is Max Tegmark's idea that the universe is all mathematics, and he has his level 4 multiverse, which basically says that anything, since Gödel tells us that there's no end to the possible structures of mathematics, there's therefore no end to the possible mathematical universe is if mathematics is the fundamental nature of reality. That's what it is. And so it's an interesting idea. I certainly agree with Gödel's incompleteness theorem. It's a theorem that no formal system, if it's complete, I'm sorry, if a formal system reaches a certain level of sophistication and it's consistent, then it's incomplete. And that means human reasoning. Human reasoning, if it's consistent, must be incomplete, which means that there's going to always be limits to what we can do. Now, the reason I like mathematics for a couple of reasons. First, it's really easy for us to fool ourselves and think we know more than we know. And it's very easy for us to say stuff imprecisely and then dodge and weave when people try to point out the holes in our stuff. So I have absolutely no interest in that. No interest in doing that kind of thing. For people who just want to, are interested in saving their reputation and not being shown wrong, well, that's if you want to do that, that's fine. I have no interest, and science basically has no interest in doing that. We want precision so that we can figure out where we're wrong. That's the whole point of using math. Well, one of the main points, not the only, but a main point in using mathematics is so that you have to make your ideas absolutely precise, so that now people can really take shots at them and say precisely where they think you're wrong. So it gets rid of the hand wave and, I didn't mean that, and so forth. It just gets rid of all that. That's just a waste of our time. It's nonsense and a waste of our time. By the way, it can lead to dogmatism and fighting and the whole bit. So it helps to get around that kind of nonsense as well. Scientists are dogmatic as anybody, but eventually other scientists will show you with mathematics why your own ideas aren't right. So eventually you'll have to let go. Right? Someone who believed in Newton in 1922 will eventually be shown that that's, you're on the wrong side of the math. So that's one reason why I think I like mathematics. It forces us to be precise about our ideas. It gets away from this dodging and weaving and just protecting ourselves from being falsified and so forth. But the other thing is, then that's the sort of the downside, the negative side of the things that you're avoiding. But here's the positive side. Once you've made your ideas precise, mathematically precise, then you become a student of your own theory, because the mathematics then of your own theory takes you places that you probably never thought it would take you. Like I think I mentioned before, Einstein's theory of gravity. He didn't know that it entailed black holes. A guy named Schwarzschild found that solution to Einstein's field equations. And about a year or so later, after Einstein published his equations, Schwarzschild sent Einstein these solutions. Einstein didn't know that. His theory came back and said something he didn't like. It said that there are black holes. And Einstein was really upset about it. He did not like that idea at all. And so that's another reason why we do mathematics, is because we're not smart enough to understand all of the implications of our basic assumptions. So I write down, I have a set of basic assumptions that I build into my scientific theory. I'm smart enough to come up with those assumptions, but I'm not smart enough typically, even if I'm an Einstein. And I'm no Einstein, so there you go. For those of you who are smarter than Einstein, maybe you don't need this. For the rest of us human beings that are not smarter than Einstein, we're not going to be able to figure out all of the implications of the assumptions of our theory. So we need to write down mathematics and then follow the math wherever it leads, and then we become students of our theory. So that's now in terms of, Gödel's incompleteness theorem tells us that there's no end to the possibilities of mathematical structure. We'll never know it all. We can't know it all. And any finite theory, all of our scientific theories are finite theories. You have a finite set of assumptions, and then all of our theories are necessarily incomplete. So that means that there is no theory of everything in science. It's very, very clear. There is no scientific theory of everything. That means the upside is that's infinite job security for science, infinite job security. It also means that your theory, my theory, is necessarily incomplete. It will be overthrown. That's the way it is. In other words, when I propose a theory, I'm saying this is our next step. It's not the final step. It's our next step. And I can't wait to see the theory that goes beyond this. And this is going to be the case all the time. So this brings a certain humility to science. There's no theory of everything. And for me to really, I think most scientists who talk about a theory of everything, it's with a wink and a nod. For those for whom it's not a wink and a nod, you're just misunderstanding the whole setup here. There is no possibility for a formal, a precise scientific theory to be the final word, because it will necessarily be incomplete. It can't contain all the truths. It can't predict all the truths. So that's another reason for using mathematics. And my own feeling is that there's some, if consciousness is fundamental, this is now a separate thing about consciousness. And this is where I differ from Tegmark. And I'm, maybe Tegmark's right and I'm right and I'm wrong. Who knows? But at least this is a difference. Tegmark thinks that mathematics is the fundamental reality, and I think that consciousness is the fundamental reality. Conscious experience, like having a headache, smelling coffee, those experiences, hearing the sound of a trumpet, those experiences are fundamental. But those experiences are not unstructured. So just like my body's not, I have bones that give my body some structure. And there are other things, there's cartilage and other things that give my body structure. I'm not an amorphous blob. But I'm not just my bones. I'm not just the structure. So I think there's this deep organic relationship between consciousness and mathematics, where mathematics provides structure, but there are countless different worlds of experience that could have the same structure. So the mathematics in no way exhausts the consciousness. One can easily show that there are infinitely many different varieties of conscious experiences that could have the same mathematical structure. And so in that sense, that's why one reason why I disagree with Tegmark. I think that mathematics is infinite, but consciousness is even more infinite. So that's the difference between our views.
Yeah. So does that mean that if consciousness is fundamental, somehow mathematics arise in consciousness?
Yes. I think that what Gödel's incompleteness theorem says to me is that the very fact that we understand, well, Gödel understands, and a few people who have read his proof and studied it can understand, and in principle anybody could, or we'll put it this way, a large proportion of us could, if given the time and the motivation. That means that we're understanding something that goes beyond the capabilities of a formal system. We understand that. And my own, for what it's worth, and I could be wrong on this, but this is the way I'm thinking about it right now, is that in some sense, what we are fundamentally, when I say that we are conscious agents, that we are fundamentally a form of intelligence that is not restricted to the limitations of mathematical formal systems. We are an intelligence that can understand the limits of mathematics. We are not ourselves limited to what can be proven within any particular mathematical system. So that's another sense. I said one sense before in which the countless different kinds of experiences could have the same mathematical structure. I could have the mathematical structure of color space, and I could then imagine a sound space that had the same mathematical structure, and all sorts of other. But now that this is a different level where consciousness itself understands the limits of formal systems, period. And it's a form of intelligence that uses mathematics, it uses formalism, but it is not trapped within the confines of any particular formalism. And that seems to me to be one of the implications that human intelligence can come up with Gödel's incompleteness theorem. And so that suggests to me that there's this other aspect of human consciousness, not just the raw experiences, but this deep intelligence that transcends formal mathematics as well. So I view consciousness, and I view mathematics as an incredible tool that consciousness can use. It's an incredible tool, and and somehow what consciousness is up to is somehow exploring all the possibilities of investigating itself with that tool, which is really quite interesting. But you can see that why I don't think that consciousness just is mathematics.
Yeah, and actually, the last point that you made is really profound, and I think that's we'll dive into it, and probably we'll discuss it more. But so, since you mentioned about conscious agents itself, so how do you look at those conscious agents? How or how we can explore it in a better way? Do we think that it's more like some kind of microbots coming together? Because in the universe, one thing that we can't deny is complexity, right? I mean, even if we say that there are different symmetries beyond space-time, which physicists are exploring, that also we can talk about what those symmetries are, etc. But somehow, if these symmetries are coming together, and according to you, that basically your theory will give space and time as an emergent phenomena, and from there we can't deny complexity, right? So so how do you look at these conscious agents, and kind of, because there is this hierarchy in a way, right, that going from these probably less complex states, we can call them, to more complex states, which are probably the life forms or you and me, etc., right? How do you look at it?
Right. So I think of conscious agents as consciousnesses outside of space and time. So you have to think out of the box. You have to think out of the space. So these are not little agents inside space and time. I'm not saying that certain little particles inside space and time have consciousness in them. That's the panpsychist point of view. Panpsychists will say that you have these fundamental particles in physics, but the ultimate nature of these particles is consciousness. I'm not saying that at all. Space-time is merely a headset. It's a user interface that some conscious agents use as a way of interacting with other conscious agents. And so what that means is anytime you have a user interface, like right now we're talking via Zoom. I mean, so my consciousness is interacting with your consciousness successfully. I think that the ideas in your mind come out as questions that then put ideas in my mind, and we're having a real, but it's all going through a Zoom interface. And right now on the Zoom interface, I have some pixels. And some of the pixels are of your face, some of the pixels are of a wall, and some of them are of a desk. The pixels that are of your face are giving me a portal into your conscious experiences, and your facial expressions and so forth give me a portal into your mood and your interest or disinterest, whatever it might be. Whereas the pixels that I'm seeing right now of your desk or of the wall behind you are giving me no such information. Now, does that mean that the pixels that are the pixels for your face are like conscious pixels or living pixels? They're just pixels, just like the pixels for a rock, or a book or a desk or a wall. The pixels are pixels. Well, that's the same way with space and time, right? It's not like, so the distinction between, like on the Zoom screen, if I want to make a distinction between living pixels, right, the pixels for Jitender's face, those are the living pixels, and the pixels for the wall behind him, those are the dead pixel. Well, you can make that distinction, but it's silly. The pixels are the pixels, and if you move your head, pixels that were, wall pixels are now Jitender pixels and vice versa. So the distinction we make between living and non-living things in space and time, like rocks are not living, rabbits are living. That's not principal distinction any more than the distinction between Jitender pixels, living pixels, and the wall pixels or dead pixels. That misunderstands the pixels are pixels. Some of them give you insight into the consciousness of Jitender, and others, the wall pixels don't. So I mean, there's nothing bad about those pixels. They're not living or not living. They just give me more or less information, a portal into the consciousness. So that's the same thing, same way with everything in space and time. When I see a rock, it's like a pixel for the wall. It's giving me almost no information about consciousness. But that doesn't mean that there's not consciousness before, on the other side of my interface. It just means that, of course, an interface is an interface. It's dumbing things down. At some point, it dumbs things down so much that I can't get contact to the consciousness behind. That's what interfaces are for. So there's no distinction between living and non-living. That's not principled. That's an artifact of our interface, and no distinction in principle between conscious and unconscious from this point of view. We're always interacting with conscious agents. Sometimes I only see a rock. That's not because the conscious agents are stupid that I'm interacting with or non-existent. It's because my interface has to give up. That's, if I was going to have an omniscient view of conscious agents, I wouldn't need an interface. I'm using an interface because I'm dumbing things down. So of course I'm going to dumb things down so at some point so much that I don't have much insight into the consciousness. That's what my interface is for. So complexity, then, if you think about it, right now, the pixels on the Zoom screen for your face are doing far more complicated behaviors. The dynamics of them changing is far more complicated than the pixels of the wall behind you. So does that mean that those are really more complicated pixels? No. It just means that the pixels are being used in a different way than the pixels for the wall. So when we see things that are more and more complicated, so put it this way, once again, the distinction between complex and not complex is also an artifact of our interface. Is what does my interface give me? The complexity is out there. Conscious agents are complicated out there. They're all the time. What I can see about them, I call complexity, and I think it's fundamental. Then I reverse everything around and say, aha, consciousness somehow emerges from that complexity. And it's the same mistake as saying, well, yeah, Jitender's consciousness emerges from the complexity of the pixels on the screen. See all those pixels on the wall, they're not really, there's no complicated dynamics there, but the dynamics of the eyes blinking and the face smiling, and that's much more complicated dynamics of those pixels. So that's what's causing Jitender's consciousness. That's not causing Jitender's consciousness. That's just the consciousness of Jitender playing with my interface in a way that gives me insight. And of course, it's going to have to play with my interface in ways that are a little bit more complicated for me to get the insight into consciousness. But it's not the complexity of the interface description that causes the consciousness. It's what allows me the portal into the consciousness. So you can see the difference there. And I think the Zoom metaphor really helps bring that kind of thing home, which otherwise might be really a stumper. But it's not really a stumper. It's a simple idea.
So, this is mind-boggling stuff. When we are, in general in science, when we are thinking of, because there are these transitions that we are thinking of, right? Like the physics changes to chemistry, and that somehow, complexifies to biology. And now with this, what you are explaining, that there is no difference between life or non-life or animate or inanimate matter. So what would you say to, I don't know, at least thousands of scientists that they are working on those questions? What are they trying to explain then?
Oh, well, I think all of the science that's being done is brilliant and has to be done. What we're doing, what the scientists have been doing, what we have been doing basically since Galileo and roughly, is using mathematics and experiments to carefully study our headset. We've been studying our interface. We thought it was the truth, but it turns out, no, but we've really become much more savvy about the structure of our interface. We can actually write down, Einstein's theory of special and general relativity for the structure of spacetime. So we get mathematics for the structure of our headset, and it's a beautiful structure, and quantum theory as well. So all the work that's been done is good. But the good news is job security, like in neuroscience, right? Neurons, I'm claiming that neurons don't even exist when they're not perceived. But when you look inside what we call skulls, then you will see neurons. That's what your headset will give you. Just like if I have a virtual reality headset on and I'm playing a virtual reality game in which there's cars, say, and I turn my headset to the right and I see a Porsche. Well, I create the Porsche when I look, and as I turn my headset the other way, I delete that Porsche. Well, same thing. You create the neurons that you see when you look in someone's head, and you delete them when you look away. The neurons aren't there, but you will always see neurons when you look, because that's the way your headset works. So we've been studying the headset. There's a reality beyond the headset. Physicists are now marching out there. Okay, well, what's beyond space-time? Well, there's the amplituhedron. What is that? Well, it's just this geometric structure. It's just sitting there. It's a static structure that's just sitting there. So they have no notion yet of anything dynamic going on beyond space-time. And that's what we're hoping to provide with this theory of conscious agents. What's behind the amplituhedron? Well, there's a world of dynamics of conscious agents that leads to the amplituhedron. So the physicists have stepped beyond space-time. They're saying there's this stuff beyond space-time. So all of my brilliant colleagues in the cognitive neuroscience and in other sciences who are doing all their wonderful studies, none of it is wasted any more than Newton was wasted when we moved from Newton to Einstein. Newton was absolutely essential. Without Newton, there wouldn't be an Einstein. Without a Riemann, there wouldn't be an Einstein. So you need the mathematicians and the physicists working together to provide the tools for the next step. And then once you understand Einstein, then you can go back and respect Newton in a different way. Newton is still good for many, many problems. And all the science we're doing right now inside of space and time will continue to be exceedingly valuable. And it will be the launching point for going beyond space and time. So my cognitive neuroscience friends, when I say that neurons don't even exist when they're not perceived, that doesn't mean we shouldn't fund neuroscience. That means we need more funding for neuroscience, because it means, we thought the problem was simple in some sense. We knew it's complicated already, but at least it was simple in this sense. If I look through a microscope and I see a neuron, we assume there is a neuron. If I see synapses, that's because there are synapses. And microtubules, that's because there are microtubules. Well, now we realize, no. Those are just my interface symbols. I have to reverse engineer them. What's on the other side of space-time, right? Like the amplituhedron is on the other side of space-time. Physicists are finding structures on the other side of space-time. Neuroscientists have to find structures on the other side of space-time that project to neurons inside space-time. That's what we have to do. So you can see there's plenty of job security here. We have a ton of work. In some sense, we thought we were close to the end. No. This is step zero of who knows how many thousands or millions of steps. We've just passed level zero, and we just woke up that there's a level one. Holy smoke! And there's probably level infinity. We have a lot to go. So you can see. So I'm not at all putting down the work that's being done right now. It's brilliant. None of it's wasted, and all of it will be used to launch us to the next level. So it's all good.
So most of the science that we are doing now is basically to explain our interface, right? That's what you're saying. It's not more than that, but what is more than that is something, once we consider consciousness, is fundamental, right?
That's right. And what the physicists have done is also beyond space-time. So the physicists, when they posit the amplituhedron, they're saying, look, we found one of our first new outposts for science. Here's a new outpost for science beyond space-time. It's just sitting there. It's like the monolith in 2001, A Space Odyssey. Here we are, all these apes. We're jumping around. There's this monolith that's pointing to some deeper reality. So here's this monolith, the amplituhedron, and it's saying, there's a lot more to go. We don't know what it is, but we're quite excited. So physics is already there. They found the first monolith outside of space-time, and we're eager to. So I'm eager to follow the physicists, but I'm eager for us to go deeply beyond in other ways as well, beyond space-time.
I'm really happy to see your excitement about it. So let's talk about a bit of the experiment. So where are these experiments being done, or what is the setup that they are using?
The physicists?
Yes.
Oh, so the setup is the Large Hadron Collider at CERN. And the experiments are scattering experiments, like smashing protons together at high speeds and having gluons interact and spray out. So like 2 gluons coming in and 4 gluons spraying out and so forth. or Higgs particles being, you don't see them, but you see their decay products and so forth, see their effects. So to explain those experiments, the physicists are using the amplituhedron. So the amplituhedron, it turns out that the volumes of the amplituhedron precisely give you the scattering probabilities. So the structure of the amplituhedron it's got faces and edges and so forth. It's a complicated structure. All those faces and edges code for things that we think about as space-time. Locality, Einstein's notion of locality, you have to interact locally, and effects can only propagate no faster than the speed of light. And unitarity, which is a feature of quantum theory. And so it turns out that the locality and unitarity can be read off the face structure and edge structure, the facet structure and face structure of the amplituhedron and these structures beyond spacetime, also the cosmological polytope. So what they're finding are these deep structures beyond spacetime. The volumes of the amplituhedron code for the scattering amplitudes, and the structure of the amplituhedron codes for the properties of space and time that we know and love, locality and unitarity. So that's where, so in other words, when the physicists are proposing the amplituhedron, they're proposing something that's backed up by untold thousands of experiments and a century of mathematics that's been trying to make sense of all those experiments. So this, in some sense, you don't need more experiments to know that you're onto something. When you are able, with one or two term computations, to compute exactly the right answer for something that in space-time takes you millions of terms, you know that you're onto something. You're getting the right answer, and you're seeing a symmetry that you couldn't see in space and time. So you know, I mean, it doesn't mean that you're the final word, but you know that your mathematics is capturing thousands of experiments in the mathematical form. So that's why, Nima's giving a whole semester course at Harvard on this stuff. If this was nonsense, you wouldn't be spending a whole semester at Harvard talking nonsense. They know that even though it's not the final word, they can account for thousands of experiments to many, many decimal places. So the amplituhedron is the real thing. Now, they would say, of course, that what they have. And again, there may be some advances that I'm not aware of in the last few months or a couple of years, but there's a distinction to make between supersymmetric theories and non-supersymmetric theories. And the amplituhedron, my understanding is that at least the versions that I studied, maybe they've made progress in the last 3 or 4 years, are more for supersymmetry. When you and so they're looking to extend it to non-supersymmetric cases. But in the cases that they do account for, they get good answers, and so that doesn't. So the fact that they haven't got the whole thing doesn't mean that they're wrong. It just means that they've made an incredibly important step. And if supersymmetry is false, we still have this monolith beyond space-time that will be staging grounds for making the next foray to the non-supersymmetric structures, beyond space-time. So the only reason I'm hedging right now is, for all I know, that the physicists have already done that, and they would have to say, Hoffman, you don't know what we did in the last couple of years. We've gone beyond supersymmetry.
Yeah, and what is I think you've already mentioned that most of the physicists, they don't agree with consciousness being fundamental in the universe, right? Even if so for example, the major theory right now is quantum field theory in physics. And of course, we still don't understand what it means. And the reason being, it's just this measurement problem, right? And that's where most of the scientists are putting their bet that maybe once we understand that, or somehow once we combine quantum field theory and general theory of relativity, we'll find the answer for consciousness as well, right? But taking consciousness as fundamental, do you think it can help us explain or fill that gap as well?
Yes. So on the first part of your question, that's my understanding that most of the physicists do not take kindly to the idea that consciousness is fundamental. I saw that firsthand when I was at the Foundations Questions Institute conference in Banff a few years ago on the role of the observer in quantum theory. And I went there thinking that I would find, a lot of physicists interested in, the idea that consciousness might be fundamental, and I found that it was not the case. Now, so there may be some that are out there, but I found that it's certainly not the received opinion, and I think it's if any of them have that opinion, it's a very small minority, is my understanding from that experience. So how could a theory of consciousness, in which the idea is consciousness is fundamental, help in physics? The structures that the physicists have found beyond space-time have no dynamical notion. So the amplituhedron is this it's not a polytope, but it's a geometric structure. The cosmological polytope is, as its name says, a polytope. So it's a geometric structure. And at the heart of these, what's interesting is at the heart of the amplituhedron, I'm less familiar with the cosmological polytope, so I'll only talk about the amplituhedron. I think there may be similar things to be said about the cosmological polytope, but I'm not up on it enough to say. So on the amplituhedron, the core behind the amplituhedron is something called the non-negative Grassmannian, and behind that is something that are called decorated permutations. And a permutation is something pretty simple. Like if I have the numbers 1, 2, and 3, well, a permutation is 3, 2, 1, 1, 3, 2, and so forth. There are 6 permutations. So believe it or not, behind all these monoliths behind space-time that are doing all this amazing stuff, the physicists are stunned that there are these things called decorated permutations. They're permutations with just a little bit of extra gee whiz to them. And if you want, we can go into the gee whiz. As if you instead of permeate, if you have n things and you permeate 1 through n, you do the permutation always to the right. So you have to permute the numbers from 1 to n always to the right. So a number always permutes. If you want to permute to your left, like if you want a 3 to go to a 2, we have to wrap around n and come back to 2. So that it's a decorated permutation. So it's literally you're permuting from 1 into 2n, between 1 and 2n instead of 1 to n. But anyway, just think about it as permutations. So permutations, and possibly that's the supersymmetric case. You'll also need helicities if it's non-supersymmetric. But that's it. These decorated permutations, perhaps decorated also with helicities, that's all of the physical content that's needed. It's truly stunning, but it's just sitting there. Permutations of what? For what purpose? Who's permuting what and why? What in the world's going on here? And where did these helicities come from? So in our theory of conscious agents, we are offering a dynamical model of what's going on. So there's a way of representing our conscious agents such that if you have 5 of our simplest conscious agents interacting, each conscious agent only has one experience, like this conscious agent perceives red, that one perceives green, that one perceives blue. If you have n agents interacting, say 5 agents interacting, then it turns out we can write down a 5 by 5 matrix where the rows sum to 1. Each row, all the numbers in a row sum to 1. It's called a Markovian kernel. But for those most people know about matrices. So if you have n agents, you have an n by n matrix. Every row of the matrix sums to 1. It's a Markovian kernel. And that describes all possible dynamics of interactions of those 5 agents. So it's what we call the Markov polytope. M sub n is the Markov polytope of n conscious agents interacting. There we have a dynamics. And in this case, it's an interesting dynamics. It's the dynamics of the kernels. Every time, if you have a kernel, say P, when every loop of the dynamics is another iteration where you use P again. So if you do 2 loops of the dynamics, now it's P followed by P. 3 loops, it's you P, then the kernel P again, and then the kernel P. So you just do matrix multiply. So P to the n. For n steps of the dynamics, you multiply the kernel n by itself, and you get a new kernel, P to the n. In general, P times P is not equal to P. I mean, it's an interesting, the kernels for which that's true are called the stationary kernels, where P times P equals P. And those turn out to be very important in our theory. But in general, the kernels are not stationary. P to the n is a different kernel. So we can actually look in our space at the trajectories of kernels. These trajectories of kernels are how the dynamics of the conscious agents itself is evolving. So we have a space of dynamics in which that Markovian kernel space, the Markov polytope, is coding for all the trajectories of conscious agent interactions. There's infinitely many ways that conscious agents could interact, and the trajectories of their interactions are captured by this Markov polytope, M sub n. Now here's how we make the map, and we've only discovered this in the last 4 weeks. It turns out, and as far as we can tell, this is brand new mathematics. There is a canonical way to map the Markov polytope into decorated permutations. We just wrote it down. So there is a canonical way of mapping any M sub n, a Markov polytope, into decorated permutations. I have some Mathematica code that I just wrote this last weekend that does it. So you give me any Markov polytope, and any it's actually it maps individual Markov chains, so Markov kernels into decorated permutations, which allows me to then take the Markov polytope. So I'll be a little bit more precise here. Every Markov chain, every Markov kernel gets a decorated permutation. Many Markov kernels get the same decorated permutation. This means that you can take the Markov polytope, which is all these kernels, and divide it into cells. Each cell is labeled by one of these decorated permutations. We have an algorithm for taking the Markov polytope, breaking it into cells, and giving them precisely the right decorated permutations. And then just this morning, I proposed to my team the mapping between our decorated permutations and the decorated permutations of physics. So we'll see if I'm right or not, but there's going to be some mapping. If the one I proposed is correct, then I know how to take what are called the Playbit graphs, which represent these decorated permutations of Markov polytopes, and convert them into what are called the on-shell diagrams that the physicists use to create things like the amplitude-hedron. They code for their decorated permutations. So we have a mapping between decorated permutations from the Markov polytope into the decorated permutations that underlie the amplitude-hedron. That means that even if the physicists have no interest in our notion of consciousness, so they say you can take your consciousness and keep it, they might still be interested in the fact that there is this deeper structure than the amplitude-hedron that's deeper than the decorated. It's a dynamical structure that gives rise to the decorated permutations that give rise to the amplitude-hedron. So they could say, we think that this is a dynamics of something else. Forget consciousness, that we want a dynamics of something else. But anyway, we have a dynamics of something beyond space-time now that can actually give rise to the decorated permutations that give rise to the amplitude-hedron. So, but from my point of view now I'll take our stuff seriously. Consciousness is fundamental, I propose. These Markov polytopes tell you all possible ways that conscious agents can interact, and the decorated permutation then classifies them into groups, which then notice that's simplifying. It's taking a whole bunch of these Markov interactions and putting infinitely many of them and saying, here's one description. This one decorated permutation captures all of you guys. Well, that's what you call a user interface. That's where you're dumbing things down. So this is how you go from a dynamics of conscious agent. You use decorated permutations to build a user interface to simplify things. And so that's how we're making. So the idea would be then, we should, once we get this worked out, and if the thing that I proposed this morning to my team, I mailed it off to them, a concrete proposal of how we get the basic black and white vertices. So there are these basic black and white vertices out of which all of the on-shell diagrams that the physicists use are made. And I propose a precise Markovian class of dynamics that corresponds to the white vertices and another one that corresponds to the black. So we'll see. If that works out, then we will be able to go from conscious agent dynamics to literally, we can use the amplitude hadrons kind of thing and say, okay, pulling the amplitude hadron back, we can get this decorated permutation. We can now look at that decorated permutation. What does it mean in terms of the conscious agent dynamics? We can then say, this is what we claim is the conscious agent dynamics. That's 2 gluons in and 4 gluons out scattering. That's what this should do. That's been my goal for the last several years. I mean, last 3 or 4 years is to be able to do that, to say this dynamics of conscious agents corresponds to what we call 2 gluons in, 4 gluons out scattering. And here's why it gives exactly the right scattering amplitude. So that's what we, and once we can do that, then all of a sudden the physicists are going to have this whole new playground in which there's this dynamic, the amplitude hadron is no longer just the static structure, there's a dynamics behind it. That's going to give us a lot more insight into what's really going on. And by the way, there are many structures in the conscious agent dynamics that you have to get to a certain complexity of the conscious agent dynamics before you get to the minimal complexity you need to start at the bottom of what they see in physics. So we're seeing all this dynamical structure that you can't see in space-time. So I'm going to be very interested to see if that leads to dark matter, axions, and so forth. All this stuff in the dynamics of conscious agents that it's dynamics that isn't complicated enough to get to what they call the white and black vertices that are the basic elements of the on-shell diagrams for the physicists. We're seeing all this stuff that is not complicated enough to make it to these white and black vertices, but it's there. I mean, you can't ignore it. It's there. And so space-time, because space-time is only seeing some of the Plabic graphs that of the conscious agents. It only sees some of them. It can't see all of them because of the limitations of space-time itself as a data structure. And so that may be why we have all this dark matter and stuff that is just it's a necessary limitation of the data structure of physics, space-time itself in physics.
Well, that's
I'll answer to your question. But.
Yeah, no, that's interesting. So does this mean the dynamics itself? Because dynamics. I think of dynamics in a way. It's like the interaction between different conscious agents, and more interaction means more complexity. Can we look at it in this way?
Well, that's the way I'm doing it mathematically. That's what we're doing mathematically. Is we can have when we have n agents interacting, the number of the Markov polytope, which describes all the possible ways that they could interact, has n to the n vertices. It explodes. So I wrote a program. When I got I printed out all of for every vertex, what is its decorated permutation is. But when I got to 5 vertices, there are 3,125 vertices for just 5. So for 5 agents interacting, the Markov polytope is inside this. I don't know how many dimensional space it is. It's but the vertices. I guess we could. I'll figure it out. But we could figure out how the dimensional space. But the number of vertices is 3,125. Okay, this is non-trivial. So to understand all the possible ways that consciousness could be interacting with, very, very complicated. So we have to now to really get to your question though, because it's an important question. I'm starting with this piecemeal way and building up more and more complex things. One could argue, look, there's one deep consciousness. There's this one all-encompassing consciousness. And what we call the Jitendra and the Hoffman consciousnesses are just projections of this one consciousness. So Hoffman, your whole approach is starting with these little one bit, they only see one thing and building up. That's completely wrong-headed. You need to start with the one big consciousness and then show how all the little consciousness are projections. And that may be true. That may actually be true. But here's why we can't do that as scientists. It's impossible. And this is, once again, gets to Gödel's incompleteness theorem, is that any scientific theory will necessarily be incomplete. If it's consistent, it will be incomplete. But we really see it here with the theory of consciousness. If I take a countable infinity of these conscious agents, just these conscious agents that see one thing, each one see, red, I see green, I smell garlic, I whatever it might be. Just take a countable infinity. That's an infinity that's the same size as the number of integers, right? That's a countable infinity. It's a theorem of our theory. It's trivial to show that anytime you have two agents interacting or not, they constitute another agent. If they're not interacting, then it's just a tensor product. It's a non-trivial. It's a trivial, but nevertheless, the mathematics is the mathematics. They're an agent. They are an agent, and if they're interacting, then it's non-trivial. So when you have a countable infinity of these low-level agents, you have the power set, which is the set of all subsets, is the new collection of conscious agents that arise from them, right? Well, the power set is a different size of infinity. The countable infinity is called Aleph 0. The Hebrew letter Aleph is used for some reason. Aleph 0 but Aleph 1 is the power set. So we would now have Aleph 1 conscious agents. And that's going to be a lot to study, all those conscious. But now we can take the power set of them because all of their combinations are conscious agents. So now we have Aleph 2 and then Aleph 3. So there's no end. This is called Cantor's hierarchy. There's not one infinity. There's an infinite level of infinities. And so it is true. Our theory says that all these agents are one agent. But we need to be able to go to the limit of Cantor's hierarchy as the hierarchy level goes to infinity. I don't know of anybody who knows how to do that. So a billion years from now, maybe we'll be at Cantor's hierarchy level 1 trillion, and we'll be just really, break open the champagne and so forth. We've analyzed all the conscious agents up to level 1 trillion of Cantor's hierarchy. Well, we have infinitely far to go. So if there is the one, and I'm not saying that I suspect that there is, it will forever transcend our theory, and our theory can only proceed in this way. We can only climb Mount Everest a little bit at a time, but we'll never reach the peak of Mount Everest. We'll never get to the one. But we'll always have this very humble, we'll be, of course, exhilarated that we got to such and such a level. We now are to level 50 of Cantor's hierarchy. But we'll always have this humbling note that, well, you only have infinitely more to go. So it'll be the humility that's required of our science will be staring us in the face all the time.
Yeah, that's amazing. So, and what do we think of objective reality itself? I mean, if we think from the, again, conscious agents perspective, that, okay, I mean, we get through conscious agents, we get also our interface. But then there is, because it's about the thing that you mentioned before, that once you look, the neurons are there, but once you are not looking at it, the neurons are not there, right? But
right.
Is there an objective reality?
Well, not space and time. That's not the objective reality. That's merely a data structure that we use. So space and time, physical objects, the moon doesn't exist when you don't look. Einstein asked that. Abraham Weiss, I think, talks about that question. And the answer is from physics and evolution, and that the moon doesn't exist when it's not perceived. In fact, it's a theorem of quantum theory. That even if you can predict with probability 1 the outcome of measurement, you can predict without interfering with the system with probability 1 what the outcome will be when you do make the measurement. You can prove that there are cases where you can actually prove that the value does not exist until you make the measurement. Even though you know with probability 1 that you're going to get it, you can also know for certain from the mathematics that the value didn't exist until you made the measurement. So that's what you expect of a user interface. You get the value when you use the tool. I see the Porsche when I turn my headset, and now I see a Camaro when I turn my headset that way. So but the Porsche wasn't there until I looked and created a Porsche, and the Camaro was not there until I look and create the Camaro. And my neurons aren't there until you look and create the Camaro. Now, in this theory of conscious agents, the only notion of an objective reality then would be consciousness. And if it turns out there really is just one, and that's my guess, that there is one conscious agent, and that the tools that we're using with my team is the best that we can do as science to sort of crawl our way up to modeling that conscious agent. But if that's the case, then the objective reality is that one consciousness, that one infinite intelligence. And Jitendra and Don are merely that consciousness, that one consciousness, putting on two different avatars in a space-time headset. So there's the Jitendra avatar and the Hoffman avatar, and those are just two avatars, but it's one and the same consciousness peering and talking to itself. And so one of the deep questions for a theory of consciousness is, why does this infinite, if there is an infinitely intelligent consciousness, why does it put on different headsets? And why does it let itself, in some sense, be deluded? Why does it choose to plunge into a world as a baby, where it doesn't even, in some sense, know the rules, and have to be at the whims of quote parents and their upbringing techniques, their parenting techniques, and slowly wake up to its own realization that I'm not just this tiny little 100-pound thing inside space and time. Space and time is a data structure that I created, and this billions of light years across universe that looks so fantastic with trillions of galaxies, I'm not this tiny little speck in that universe. That entire universe is a little speck in terms of the possibilities of my creative powers. That's just a tiny little speck of my intelligence. So that's the real deep question that comes out here is, why does consciousness do it? And it may be Gödel's incompleteness theorem in the sense that there may be that consciousness itself, even this infinite intelligence, there's a sense in which the process of knowing itself is endless in principle. There's no end to itself, so that's one direction to pursue. Another direction to pursue is my friend Perry Passaro, who's very advanced in terms of spiritual thinking, and so he's thinking about consciousness in terms of love. And he said, what does love mean? If in some sense you need to plunge into a virtual world and put on different avatars so that you learn to love yourself through the avatars. So because if there's just one consciousness, what does love mean? So that's, again, I'm not saying that I've worked it all out, but these are interesting directions to pursue. So these are not final answers. These are like pointers to the directions where I want to think. So I'm not saying that I've got these answers worked out, but just as hints about the way I'm thinking about these deep questions about, if there is just one consciousness, what is it up to and why? Why is there dynamics? Why is there, violence? Why does the world behave the way it does? I mean, ultimately, we would like to understand, if there's one consciousness, well, why are some of its avatars, killing other avatars of that one consciousness? Why are some of them torturing? And of course, some of them are being very kind to other avatars. So what is consciousness doing here, and why? So this changes the whole view of morals and so forth in our understanding of things. You can see once we let go of space-time, basically the whole game of how we think intellectually changes. So
yeah, so this is fascinating, and I think one frustration is that probably we don't have the language to talk about this stuff, because when especially, let's say, when you say that, okay, we look for a reality through only our interface, right?
Right.
Means there is something outside, right? And that's what basically what you're trying to do with the conscious agents, and trying to put them together and see what sort of geometries you can get from there, right? That means that'll be already an objective reality, which would be beyond space time, but it
Right.
will exist. I mean, that's where you are going, right?
Right. Well, the consciousness would be those Markov polytopes then would be just the best that our limited science could do, right? So that puts a humbling note on the Markov. I mean, I'm really excited about these Markov polytopes because it seems like a natural next step in our science, but there's going to be many more steps beyond it. And the Markov polytopes themselves, my guess is they may be an important element, but they'll be much to say that they're objective. I would say that's a good question. In some sense, maybe the only objective thing would be the one conscious agent, and all these other things are just models. They themselves are just conceptual representations, right? So the conceptual, like, again, the map isn't the territory. My theory is just a map; it's not the territory. So I would have to say that the Markov polytopes are just a better map to, and they're a better point. Space-time is pointed to consciousness. It's one map. The amplituhedron is another map, and now these Markov polytopes are yet a deeper map, but there's still a map. And maybe one way to deal with the kind of limitation and frustration that your question, I mean, naturally raises is, right, we're always, as scientists, only going to be trapped in writing down conceptual theories. And so we'll always be trapped with that's not the reality. That's just another map. But I think the interesting thing is, from this point of view, the best I understand this point of view right now that I'm working on is there is this one conscious agent. It has unbounded intelligence, and that's you and me. And we can't. So you and I are not divorced from that unbounded intelligence. We are that unbounded intelligence. Our conceptual tools will always only scratch the surface of that infinite intelligence. But we can't know ourselves, our intelligence, conceptually, but we can know it by being it, right? So this is where science, this kind of science and spiritual traditions dovetail, where spiritual traditions have said sitting in silence and letting go of all maps. Once you really let go of all maps, then you become in touch with that infinite intelligence that you really are. And in some sense, with that infinite intelligence that leads to something like Gödel's incompleteness theorem, where you can understand the limitations of the mathematics itself. That's the infinite intelligence that can use the mathematics to point to the realm that's entirely beyond the mathematics. And so this might be more than just abstract nonsense. It may be very practical for us as scientists. Maybe the way we need to do science is to consciously choose to spend some of our time in our mathematics and our experiments in hard-nosed, and then spend equal amount of time or a fair amount of time in absolute silence, being in touch with that infinite intelligence, and go back and forth to learn to do that consciously, so that we get the insights. We can then get insights from this infinite intelligence that we are, and then port that down into mathematical structures and experiments, and go back and forth between the two. And maybe as we do that, we'll be getting more insight about why consciousness plunges itself into interfaces in the first place. That somehow there's something very deep about the infinite intelligence doing that. I mean, you could say it's just a game, possibly. Consciousness is diverting. It's a diversion, right? It's sort of a fun thing to do, but it could be deeper. It could be that this is necessary for consciousness to really understand itself at ever deeper levels. So this sort of your question does reach a very deep thing. I mean, are we forever going to be stuck behind these little models and never know the truth? Well, if you are the truth, then you're not stuck. But you have to learn to know that truth by letting go of your concepts. So whenever you have concepts, you want them to be precise. No messing around, no dodging and weaving, all that stuff that we talked about. And that's not interesting. But so when you want to say conceptually what you think about yourself, then you use really precise concepts. But then to go to the next level, you have to go to that infinite intelligence, which you are. And there you have to go in absolute silence. Any concepts will get in the way. So that, in that sense, maybe we don't have to be frustrated. We just have to wake up to who we really are and tap into that deep intelligence.
Yeah, so one interesting thing is that you are using this infinite intelligence term. So you think that once we take consciousness as fundamental, intelligence becomes part of it? I mean, taking or thinking of intelligence in a way like a problem-solving strategy or something?
Well, so I see your point, but I'll put it in a slightly different way. If we assume that consciousness is fundamental, and we assume that there is this one infinite consciousness, then it would be the case that the right way to do science, what's going on right now then, from that assumption, is that in fact the distinction between Jitendra and Don is not fundamental. We're one, we're the same infinite intelligence, just with different avatars. And what's happening is, through this conversation of these avatars, the one intelligence is continuing to learn about itself in that way. And all of our interactions, not just in science, but in art, in music, in drama, in sports, all the things that we do are just, so this is not just Geekville and only science. No, it really opens things up in a very, very different way. I mean, it means that all varieties of human activities and all varieties of activities of other animals, because they themselves are just our representation of other avatars that consciousness is taking on. Here's consciousness being a mint leaf. Here's consciousness being a palm tree. Here's consciousness being a cat. Consciousness trying on all these different avatars, all of them different ways of exploration. And so the Geeksville science stuff is not the end all and be all. It's just one of many, many different ways that consciousness is exploring itself.
Yeah. So the major pain would be to explain the perception of self itself, like how this comes into existence, or what is that, like how that dissociation happens from the major or universal consciousness, if you can call it.
Right.
So the interesting thing is, or that's what you said, that it'll be difficult to explain that part, right?
Well, it's certainly, I can't say that I've got a final explanation. So in that sense, yeah, I mean, I can't claim that it's not difficult when I can't give you a final answer, but I can give you a direction that I think is really interesting on this. And this is again where science and spirituality intersect in very interesting ways. So the notion of the self that you brought up and so forth. It turns out that we can write down a dynamics of consciousness, it's straightforward to do it, in which there is no notion of entropic time. There's the entropy of the dynamical process is not increasing, so there's no entropic arrow of time. It's trivial to do that. But it's also trivial to prove that if you take that Markovian dynamics and you take any projection of it by, say, conditional probability, so here's this dynamics. It's a dynamical sequence, but there's no entropy of time. I'm now looking at it from a particular perspective and taking a projection of that dynamics. So I'm getting a projected dynamics, right? I'm getting a new view of the dynamics. It's a projection of that. My view of the dynamics will have entropic time. It's a theorem. It's a 3-step. So you will, that the dynamical system that you get by projecting the deeper dynamics will have increasing entropy. Well, that means that you're going to have a limited time. Entropy is things falling apart. You have time, which is now the fundamental limited resource. You have probably as a result of that, all the other limited resources that we have. So all of a sudden, now you get evolution by natural selection. We're competing, nature red in tooth and claw, competing for. This is all an artifact of a projection of a realm in which there is no competition, there are no limited resources, there is no entropic time. But when you look at it from a limited perspective, from that perspective, you get evolution by natural selection. So, by the way, I don't want that to be a hand wave. I want it to be a theorem. I want to get evolutionary game theory, evolutionary graph theory, mathematically from a theory of conscious agents by projection. And the theory of conscious agents has no limited resources, no competition, but the projection, because it loses information, leads to all this stuff. So that's, see, just like we want Newton to be a special case of Einstein, and we get it, for example, as the speed of light goes to infinity, that kind of thing. I want to get evolution by natural selection. And therefore the notion of this gets to your notion of a self. Why do I have a self? Well, I'm competing against you and everybody else. And so we have all these selves because we're fighting for limited resources. And so that self would also be an artifact of the projection. And so what consciousness may be doing is every time it takes a view of itself, it necessarily view of itself I'll use capital S for the deep conscious, the deep one consciousness. But there'll be all these little lowercase selves that are associated with the avatars. When you put yourself into now you have this little avatar that's fighting. It has the appearance that it needs to fight for limited resources and fight against this the ravages of entropy and time. And that's all just an artifact of the projection. And so what maybe consciousness does is it puts itself into these little avatars with the illusion of entropy increasing and the illusion of limited resources, and therefore the illusion of a self that needs to compete with everybody else and other animals and other people. And what consciousness does is it eventually wakes up and realizes, oh, I don't need to compete. We're all the same self. And what I thought was my death, is the end, the very end of me is nothing more than me taking off this headset. So it changes the whole thing. So you can see the self then would be a necessary artifact of having a headset. And when you wake up to it, then the fear of death changes. It's not the dying of the light, rage, don't go gentle into that dark night, rage against the dying of the light. I mean, that's the attitude I would have if death is the dying of the light. But if death is not the dying of the light, it's merely changing of the headset, taking off the headset, then that's a different kind of thing. So
one interesting thing that I understand here is, so for example, in simply modern science, once we take matter and and from there we look at complexity in a way that, so there is this scaling up phenomena, right? I mean, that's what we consider. And from your explanation, what I get or the feeling that I'm getting is that we are talking about the dumbing down process, that as you said, that there is something universal out there. And when it kind of dissociates into or projects into, a kind of self, what we call, it's more like dumbing down the process. Right?
That's right. That's right. It's basically what Gödel told us, that the notion of truth is infinitely more complex than the notion of proof. The things that we can actually access through a conceptual system are trivial compared to the things that we cannot. And that's so every headset that we put on will be a trivialization in some sense of the infinite complexity of that one consciousness. And as science, then all we can do is climb up the Mount Everest and of modeling that one consciousness. But we'll know that we can never get there through our concepts, but we can be there by letting go of our concepts. We can just be there.
Yeah, so in the same sense, when we're talking about the projections itself, so can these or would these projections be discrete or continuous in a way that the can we say that, uh, for example, sapiens would have, I don't know, more of these, the conscious agents which would make that projection. So, or the dumbing down process is like kind of to the same extent, no matter we take bacteria or another animal or something.
Well, our headset has only three spatial dimensions and one dimension of time. It's probably fairly trivial compared to other headsets. What about 50 dimensions? There are many times when I've been working on a mathematical problem and I can only visualize things in 3D that I go, gee, this is a serious limit that I can only visualize things in 3 dimensions. I mean, it'd be a real big help if I could visualize them in 4 or 5 or 10. I mean, but I can only visualize in 3. Why shouldn't consciousness, the one consciousness, try on headsets with 5 million dimensions of space? Why not? So, in other words, we may think that we're the epitome of evolution, and the brain. We always are happy to say the brain is the most complicated thing we know of in the entire universe, and so forth. We pat ourselves on the back. Well, my attitude is 3 dimensions of space isn't terribly impressive to me, frankly. And my guess is that if our avatars here are appearing as avatars in some other headset of some other agent that's working in a 10-dimensional space, we may look like as dumb as cucumbers to them. And if we can understand the conscious agents behind a cucumber, we might fall down and worship them. They might be so far beyond us. I mean, just because we see a cucumber doesn't mean that the conscious agents we're interacting with themselves may be using, outside the headset or have headsets that make ours look like playthings. So in other words, we have to be really, really careful here. We like to congratulate ourselves. We're the peak of evolution and so forth. This changes that whole game completely.
Will we understand ever this one unified conscious agent, or it'll be always that will end up with the models, as you said, these are the models that you are using, right? What do you think?
Well, I think the answer from Gödel is that whatever objective reality is, whether or not my idea about, suppose my theory of conscious agents is completely wrong and the idea of one conscious agent completely wrong, no problem. Already we know from Gödel's incompleteness theorem that whatever the reality is, our science will only scratch the surface. We will never have a theory of everything. But so it's a fortiori true of my approach, where I'm thinking that it's the one conscious agent, and that you and I are that one, just avatars of that one. Yeah, absolutely true in that case, but it's true in any case. This is just a theorem. What's nice about it is that what's interesting is think about it this way. The Enlightenment, right? The Enlightenment was this major advance where we let go of authority and dogmatism, and we really we valued the individual and reason, and that led to the proliferation of science and so forth. And so there's the Enlightenment value of the individual over the state, reason over dogmatism and authority, and of course experiments to test the results of your reason. Now, so reason from the Enlightenment has been like king, but now we understand that reason itself says that if reason is consistent, then it must be incomplete. That's what reason says. If reason is consistent, then it must be incomplete. And that means that the reason which gave us the Enlightenment tells us, that very same reason which is the foundation of the Enlightenment tells us that the reality, whatever it is, will always transcend what reason can know. And so whether or not you make that objective reality, spiritual reality, consciousness, whatever that reality is, reason tells us to be humble. That the fruits of our reason will always be incomplete, or they're inconsistent, in which case we can't trust it at all. So if our reason is inconsistent, then it's just a pointless game. If it's not inconsistent, then it must be incomplete. And so that's just the way the science game has to be played, and human understanding has to be played. Spirituality aside, anything that I have to say aside, that's why I say there's no scientific theory of everything.
Yeah, so one important question is, so then can we really explain qualia, even if we take, for example, conscious agent theory, will be able to explain that? And what about, for example, and since we were talking about self itself, what about the free will and these properties that we associate?
Right. So the notion of explanation in science is that I ask you to grant me certain assumptions, and if you grant me those assumptions, then I'll explain something else. Like Einstein says, grant me the speed of light is universal. Everybody will measure the same speed of light, and that the laws of physics are the same in any inertial reference frame. You grant me those two assumptions, then I can give you this wonderful theory of space-time. But when it comes to qualia, for example, what is it going to mean to explain qualia? It means that, okay, if you grant me something else, then I can explain qualia. So what else am I going to grant? Well, what is more fundamental than the qualia, right? So I'd have to have some notion of what's more fundamental than qualia. So when we get to what's going on with my brilliant colleagues who are studying consciousness from the physicalist point of view, what they do is they say, well, grant me neurons, for example, or quantum states of microtubules in neurons. Or grant me some complex system like neurons that has the right kind of integrated information. And then I will tell you that consciousness somehow emerges from, so I will try to explain consciousness as emerging from that kind of structure in something in space. Or global workspace theory, Stanislas Dehaene and Bernard Bars and others, where it's the working memory that, and the contents of working memory that have, where they have access to a broader range of the network or of the system, those somehow give rise to consciousness. Now, so these are all trying to explain qualia in terms of like integrated information, orchestrated collapse of microtubule, quantum states, global workspace states, things like that. Now, the remarkable thing is that none of these theories has yet to succeed in explaining any specific conscious experience. What is the integrated information that must be the taste of chocolate? I asked that to Giulio Tononi back in the late 1990s at the Helmholtz Club and at UC Irvine, late 1990s. We came and gave a wonderful talk to us. And I asked him a few years ago, and there's not a single specific conscious experience. And this is true of all of these theories. And Steve Pinker in his book Enlightenment Now, he likes the global workspace theory, but he points out that any connection between global workspace states and specific conscious experiences is stipulated. The theory doesn't predict any conscious experience; it stipulates. He says, and Pinker is he's very clear-sighted about this stuff. He's a brilliant thinker, deep thinker. And he's not going to try to fool himself. And he's very, very clear. It's stipulated. The connection between the theory of, in this case, global workspace, but it's also true of IIT, integrated information theory, and orchestrated collapse and so forth. Right now, any connection between a specific conscious experience and a specific integrated information structure or global workspace structure is entirely stipulated. There is no explanation going on there. It's stipulation. And so Pinker says, in the Enlightenment Now, so we may just have to accept that we have to stipulate these conscious experiences. So my attitude about it is, I agree with him. Pinker's a good friend. He was my professor The last year I was there at MIT was his first year. When I was a graduate student, he was his first year as a professor there. I took a class with him, and I've been in his debt ever since, intellectually. I mean, he's brilliant. I've learned it was his work that got me into evolutionary psychology and using evolutionary game theory and so forth. It was really his work that made me take it seriously. So Baker says we're going to have to stipulate this connection between these physicalist theories and specific conscious experiences. And I agree with him completely. So my attitude is, if we're going to stipulate the conscious experiences, and we have to stipulate them, then let's stipulate nothing else. Why stipulate space and time and neurons and integrated information and orchestrated? Why stipulate all that stuff? If we're going to stipulate the conscious experiences, let's take a nod to William of Ockham, use Occam's razor, and stipulate nothing else. Let's force ourselves as scientists to write a theory in which all we stipulate are conscious experiences. We stipulate the dynamics of conscious experiences, and we prove how space-time comes out of it, and we prove how it looks like global workspace theory and integrated information theory and so forth as merely an interface representation of this deeper thing. So that's my attitude. But ultimately, I mean, your question is even deeper than that. It's about my work taking consciousness as fundamental, and absolutely, your question points to a limitation in what I can do as a scientist here. There will be, any scientific theory will stipulate something as the foundation. So I'm stipulating conscious experiences. I don't know how to get beyond that right now. So no, I can't get beyond it. But the difference between what I'm doing and what the physicalist is doing is I'm stipulating only conscious experiences. They're stipulating conscious experiences and space-time and all this other physicalist stuff. I want to show that I can get space-time and all that stuff from the stipulation of conscious experiences.
I mean, that does make sense, but what's your even feeling we can talk about? Like, can we explain qualia with consciousness being fundamental?
Well, I'll have to admit that right now, I have no idea about how to explain qualia. What I can do, and this is something that I presented at a talk at Chapman University. It was, I think, sponsored by FQXI, FQXI sponsored conference, where I show that if you grant me certain agents with qualia, then I can show how those agents can fuse and create new qualia. So I can explain, or I can have a scientific theory that models, right? It does, in some sense, even the word explain, we could quibble about that, but from the mathematics, it starts with two separate agents with two separate qualia, and the mathematics points to a new agent being formed with a brand new qualia. That's not merely like a quantum superposition of the two or something like that. It's literally a new conscious experience. So we can do that. But the deeper question that you're asking, could we explain all qualia? That to do that, we would have to find something deeper than qualia, right? We'd have to find something deeper about consciousness than qualia. And I'm not saying that there isn't anything deeper. I can just say that the brain in the Hoffman avatar is not capable at this point of coming up with a deeper one, at least at this point. Maybe when I step outside that brain in some meditation time and let go of all concepts, maybe that'll come to me, but right now I don't see it.
Oh, that's interesting, actually. I mean, of course, it is difficult in one way, as you said, that it's so difficult to even imagine 4 dimensions, 5 dimensions, and here now we are talking about something beyond space-time. So yeah, I mean, it does make sense. But this connection that you mentioned about meditation, or let's talk a little bit about this connection. So what do you think, what is happening there? I mean, at least in your philosophical or in your personal experiential view. I mean, we can talk about meditation, we can talk about even spiritual experiences that people have, or other kind of rich experiences through psychedelics, etc.
Right.
What do you think, what is happening there? I mean, is it that we are trying to make a connection with the universal consciousness?
Well, of course, my answer is I don't know, but my best guess is right now that there is this one consciousness with unbounded intelligence, and that um, I'm not separate from it. I'm just that in a particular humble avatar, that has a ability to only perceive in 3 dimensions of space and 1 dimension of time, and a range of colors, and I can't see infrared, and lots of things I can't even imagine a new color. If I ask myself to imagine a new color I've never seen before, can't do that. So I'm that infinite intelligence that's plunged itself into an exceedingly humble avatar and an exceedingly humble interface, and lets itself get lost in that. But I don't know. I mean, that's as far as I can go. We'll have to see.
Yeah, actually, I mean, so the last conversation that I had, it was with Bernardo Kastrup. Yeah. So, I mean, of course, when we are thinking about your work and what he's posing, there are quite a bit similarity in a way that So, of course, he talks about an analytical idealism, where his argumentation is on the similar lines that the space-time is doomed, or in his case, it's materialism is doomed,
Right.
and that's why we need to opt for analytical idealism, where the consciousness is fundamental. The basic principles or the basic points that he talks about is the fact that the dissociation from the universal consciousness, it happens at the life level. So life being that dissociative process, the and that's what his explanation about this rich experiences was. That means we are trying to make that sort of connection, so this dissociativeness, it kind of dissolves in those experiences, and we kind of get this, the rich experience in a way.
I like that.
Yeah.
I mean, Bernardo's a good friend. We're good friends. I have even, invited him to be a collaborator in terms of the math. Bernardo is a brilliant philosopher.
Yeah.
But he's also got some serious mathematical chops. And so, he and I are on the same page in terms of the kinds of ideas that we're pursuing. He's doing the argumentation in philosophical terms. I'm trying to use mathematics and science with a little bit of philosophy, but he's a professional philosopher. But I would love to have Bernardo work with me on the mathematics of it, because he's got the chops to do that as well as the philosophy, and we could use some help. And so, yeah, I'm on the same page on a lot of things with Bernardo. I think we also have some interesting differences on technical points that I think once we really, I hope to have a conversation with him again pretty soon. He and I had lunch a few years ago, and where I asked him in person over lunch, come join us. You can do the math too. Let's have, we both agree consciousness is fundamental. Let's do this math together and so forth. But I can understand him, wanting to go after the philosophical approach for a while. But I would love to have him join us on the math, and hopefully we will disagree on things, because that's where you really learn. I mean, that's so you learn to disagree respectfully, but seriously, and really prod and push on everybody's ideas. And that's how you make progress. So I'd love to do that with him as well.
Yeah, I mean, that's definitely exciting. And so his point was that at some point, the consciousness goes beyond science, like then it's just the philosophical area rather than scientific area, like after a point. I mean, so I think that's what probably you are hinting at with Gödel's theorem, that, since we are limited in explaining either one or the other factor, probably then it's just that we need to take our models, our understanding from our theories, and kind of go at the philosophical level to really explain what we are trying to explain.
Well, so I would, if Bernardo said that, then I would respectfully disagree, because I would and that would be fun to have a discussion with them, because my attitude would be that yes, science is completely limited, and the mathematical models is completely limited in modeling consciousness. The consciousness will always transcend it, but it will also transcend any conceptual system in philosophy as well, and for the same reason. Philosophy is no better off than science in this, and it can take us no further than the science can, because in both cases we're limited by the fact that we're using concepts, and the concepts, it's the fact that there are limited concepts itself that is the problem, whether they're mathematical or philosophical. The reason for bringing mathematics in is, to the extent that philosophical concepts are imprecise, they're not as effective tools as the mathematical concepts. So wherever possible, we would like to have precise concepts in our philosophy. And there are many, many philosophers who are very, very precise and use mathematical. Brian Skirms, UC Irvine, and he's a philosopher in good standing and very well respected, uses lots of mathematics and game theory and so forth in his philosophical investigations. So, mathematics is not divorced from philosophy. So I would say that it's not that where science gives up, philosophy can take over. I think absolutely not. I would love if Bernardo disagreed with me, that would be a fun conversation to have. But my attitude would be absolutely not, and for the very same reason that both are conceptual systems. It's just that one is more precise than the other. In some sense, I would say it would be the other. If anything, it would be the other way around. That we can go further with mathematics than we can with philosophy, because with mathematics, there's no imprecision, and when you have no imprecision, then you can be surprised by your theory. It's hard to be surprised by your philosophy when the concepts are not precise enough to come back and slap you in the face and teach you like that your theory means that there are black holes. Right? Philosophical theories that are not mathematical can't come back and slap you in the face that way. So if anything, I would say that it's the other way around, that mathematically precise science can go deeper than the philosophy can. Now, that's not to disparage philosophy. I myself read philosophy. I've studied philosophy, and I want to take the conceptual insights and the careful analysis and logical analysis that the philosophers give. So I think that there's an important back and forth. But if I had to bet on which can go deeper, I would say because the science, well, to the extent that science is mathematically precise, that mathematics itself comes back and becomes your teacher in a way that at least pure verbal philosophical theories cannot do.
So that means we can kind of go beyond our interface to look at the reality. Is it?
Well, we can go beyond this interface, but we can't go beyond all interfaces, because the very act of getting a science will be using a different set of concepts and therefore a different interface. The only way that we can get beyond all interfaces is to let go of all interfaces and just be that infinite intelligence. So, which is really interesting. If it is the case that you and I really are just this unbounded intelligence dressed up in an avatar that's really dumbed down compared to the infinite intelligence, then it becomes just an obvious part of our everyday science that, in addition to our conceptual analysis, we spend time, maybe as much time, in silence, in letting go of concepts and learning to let go of our concepts and getting in touch with that infinite intelligence, as much time doing that as we do spend with our concepts. And I'm now trying that out. I'm trying, okay, I've got this interesting scientific problem. What if I'm this infinite intelligence? What if I sort of put that to myself and then let go? And just, I'm not saying that I just, the way I do science from here on out is I have a good time to drink beer and see what comes to me. No, it's not that. You do your hard scientific work, you do your math, you do the hard-nosed stuff. But in addition to that, you take time out and you go, okay, let me spend an hour or two. Let me go into complete silence and maybe put this question to myself. Are there some deep, deep insights that could come out of that infinite intelligence that I am. If I am that infinite intelligence, and see what happens. That would be an experiment to find out, am I that infinite intelligence? I mean, or do I just keep coming up with the same old nonsense?
I mean, I think you've mentioned it quite a few times now about the importance of silence, etc. So why do you think it is important, or probably your feeling is that maybe we kind of are being connected with this universal consciousness?
Well, the reason I think the silence is important in this is thinking can be an extremely powerful tool. But as we all know firsthand, it can also be just sort of this repetitive thing that just goes on all the time, and sort of this constant, sort of less than useful thoughts going on all the time, judgments and self-criticisms and all these thoughts that are going on. And so it's a tool, but the tool somehow has like an energy of its, it goes on its own. And as long as you're stuck in that, you're stuck in a conceptual system. So you're stuck under Gödel's theorem with being, if you're consistent, then you're incomplete. So you're stuck with this incompleteness. Only the stuff that's accessible within that conceptual system is accessible to you as long as you're stuck in thought. So the reason to let go of thought altogether is partly because we have this, most of us have this obsessive thinking that's driven by our worries and our fears and so forth. So that obsessive thinking is keeping us trapped in the conceptual realm. So letting go of that obsessive thinking, which means calming ourselves down and so forth, is going to be necessary to finally really let go of thought altogether. If you want to let go for an hour, where you're not worrying about what people think about you, your status in the world, my car, all these things that we worry about, that keep us trapped away from the infinite. If we are infinite intelligence, keeps us trapped away from that infinite intelligence and down in the mundane stuff of this little avatar. So if we're going to really tap into that infinite intelligence, then we really have to let go of that thought, and that's not going to be easy because we're fighting all these little internal battles and battles with other people, other avatars of ourselves. So it takes some letting go in a different relationship with thought. Instead of me just believing my thoughts and being my thoughts, my thoughts are, I was born in such and such a place, my parents are such and such, and I have these degrees, and that's who I am. Just letting go of all that, that's not who I am, that's a story. That's just a conceptual system. I'm something that's infinitely beyond that, and I'm going to walk away from all that and maybe not even miss it. So if that's the case, then all this obsessive thinking about that story is getting in the way of this deeper intelligence inspiring my science. And so letting go of that story, letting go of all the shenanigans and worries and fears and anxieties and proving myself or disproving myself or trying to look good, letting go of all that, then and only then can I tap this deeper intelligence. Otherwise, I'm sort of screening it off. I'm saying I will only accept the stuff that's within my conceptual system and only fits within my model of me. That's all I'm going to let myself see. Well, we have to let go of that, and then we open up to. So in some sense, the intelligence is there. We're just screening ourselves off from it. So by not screening ourselves off from it, we let it come in. So we have this different relationship with reason and thinking. It becomes a tool as opposed to something that defines my very identity. It can't be my identity. It's incomplete. It couldn't possibly be. So anytime my thought says that's what you are, you know automatically that it's an imposter. That's not who I am. No conception could be the final reality. Gödel tells us that. But this is part of the whole, if it's consciousness waking itself up, this is all part of what consciousness has to go through to wake up, is to shed the story that it's been telling itself, that it believed, and saying all these things about me and the other, and also the stories I tell about other people. So now I can't even believe the stories I tell about other people. Whatever story I'm telling about you, that's not you. That's my really incomplete model of you, and you transcend. And so it leads to a complete different attitude towards people. That it leads to, you can't just put people in pigeonholes. You can't stereotype them. Your stereotypes are just your stereotypes. They transcend that completely. And if you really understood the reality of that person, you'd probably be in awe. But we always see just the stereotypes and the little pigeonholes. So letting that go of that pigeonhole for myself will help me let go of it for other people. And once I start beating up myself with my own concepts and so forth, and diminishing myself by I'm just this little guy, that tiny little guy, born such and such, trying really hard to be impressive, and let go of all that, then I can open up to this infinite intelligence and maybe do some really good science. Who knows?
Yeah, that's brilliant, I think. So let's try to summarize our conversation in a way. For sure, consciousness is fundamental. I think it started with an insight, but now it looks like, or if probably you think of it as a worldview, right? So thinking in that way, we can always think again. It's that there are many smart people out there, you know, that they don't know probably physics and maths, but still, they kind of follow everything. They try to understand rationally. They try to criticize everything, So they, of course, listen to you. They, of course, listen to other concepts. So what is your message to them? If we think consciousness is fundamental, and then of course there are a bunch of nerds trying to complicate things for scientists. So what is the message for them? Like, what do you think? How we can take this view in our daily lives, and how we can take this view at the scientific level. And when I'm saying about scientific level, it's mainly, let's say, biology, which is still, I think, working with classical mechanics, not even at quantum mechanics. So and now we are going beyond space time, so there is, I think, huge gap there. So what do you think, how we will progress in 21st century, taking this idea as a worldview?
Well, so the worldview then would be that I'm not just this little 150-pound lump of meat. I'm this infinite intelligence, and so are you, and so is my cat. It's not just a cat. There's an infinite intelligence that's dressed up as a cat, and the same thing as a turnip. There's an infinite intelligence there. So if that's the case, so it's not just the geeks like who are doing the science of this that are going to inherit the earth. It means that consciousness is exploring all variety of things. Being a turnip, being a cucumber, being a cat, being a geeky scientist, being a musician, being a sports enthusiast, being someone who, like Roz Savage, rows alone across the Pacific Ocean. Rows alone, a woman rowing alone across the Pacific and the Atlantic and the Indian Ocean. So consciousness did that, right? It chose to do that. I mean, amazing things. And so the idea would then be that you're not just this little lump of meat. And if I can't do, if I can't do math, that's who cares? I mean, maybe you can do music. See, I can't do music. My father was a musician. I took 6 years of piano lessons.
Wow.
When I got to John Thompson's third grade reader. That was so it was not in the cards for me. So I have complete respect for people who are musicians. I have absolutely no talent in that area whatsoever. But that's consciousness exploring its possibilities as a musician or as an artist or as a sports expert or something. So there's countless ways for consciousness to explore, and it's exploring all of them. So just because I'm doing one thing, that's not we might tend to think that what I'm doing is the most important thing. So this is one wake up call, is to say, well, no, what other people are doing is just as important. It's the same consciousness exploring everything. So let every activity flower and don't demean any other activity. I mean, it's really easy for me as a scientist to say, well, what I'm doing is the most important thing in the world, and what, someone who's packing groceries, that's not important. Absolutely not. From a deeper point of view, consciousness has decided that it wants to spend its time figuring out what it's like when I am an avatar packing groceries, and what do I learn from that? And sometimes when I'm writing equations and being a geek about science. So those are all just legitimate ways that consciousness is exploring itself. So this really opens up a really egalitarian view, because in some sense, I'm not separate from you. I am you. You are me. We're just different. It's me with different avatars. That turnip is just me with an avatar, a different avatar than I've got. So it changes the whole world perspective. And I think it really opens up an attitude of let every person pursue their own gifts. That's what consciousness is up to. There's not one right path. Whatever path works for you, that's the path that consciousness wants to take through that avatar. Go with it. And don't feel bad about it. I mean, so I can't feel bad about not being a musician. Hey, I can enjoy other people's music. Why waste my time crying over the fact that I can't do the music myself? I'll enjoy the other avatars of myself that are doing that, and wonder at that, and those who can play tennis like I could never play, and so forth, and just appreciate all the other gifts that we get from the others, which are just myself, but under a different avatar. So it changes the whole game, right? But I think ultimately, if space-time is doomed, then we are not little avatars inside space-time. Space-time is just a headset. And one day we will take it off. And we're not just lumps of meat inside the headset. We're the infinite intelligence that will take off the headset. And perhaps that's the deepest.
Yeah, that's so profound in once we start thinking in this way. And what's your message for biologists that they are still living in classical mechanics?
Oh, well, I think that there's still plenty. The way that is being done right now is brilliant work and should be continued. But we need to train a next generation that starts using what the physicists have found is beyond space-time. There are these new structures beyond space-time. And we have to ask, okay, when we see neurons and we see microtubules, and we see synapses and dendrites and so forth, how do we reverse engineer that to the reality beyond space-time? What is the dynamical reality beyond space-time that projects to what we see inside space-time as neurons and synapses and so forth? And also, higher level things like, default mode network and attentional networks and so forth. So none of the work that's being done in biology will be lost. It's all absolutely essential as we then move beyond to a framework beyond space-time, and then understand how the good work inside space-time of neurobiology emerges as a projection of this deeper stuff. So as I said before, we need more funding for neuroscience, not less, a lot more funding. And it's going to get a lot harder. It's going to get a lot more challenging, but I think even more exciting if that were possible.
Yeah, I mean, exciting times, definitely. There are, I mean, of course, in a way that, whenever this progress happens, we kind of lag in science, right? But I hope we'll catch up. So that's the, I think, final message for today's session. And then, your great idea, which is to let go. So that we can do, and then let's hope that we'll come up with new and more or better experiments to kind of connect the dots and probably reach beyond space-time.
Absolutely.
Yeah. So with that, thank you so much, Don, accepting the invitation. And I think for me, it was really important to understand your perspective at the worldview of the reality beyond space-time, because if it really works out, I think it's going to be really a kind of a big concept of 21st century, which will transform our understanding to another level.
We can hope. Absolutely.
Yeah, exactly. Yeah. Thank you so much.
Thank you very much. Thank
Yeah.
you.